standalone mode in mind. So the basic architecture, the components included in this are like, so one is a master and second ones are like worker nodes. And so you will have one client machine on which the driver program, so or the main method will get executed. Okay, so we'll see that is one thing. And so let me start downloading the Scala Eclipse IDE as well. Meanwhile, if I have to package any application here, okay. Yeah, so let that get downloaded. So we talked about these things. Running your master service, master daemon. So how did we run that? These commands will not help you with the installation that I have shown you. So there in the morning, I have started both the master and worker daemons by running this command, start-all.sh. Okay, so start-all.sh, this is starting both your master, Spark master and Spark worker machine. So they both are still running. Okay, now you can also validate them whether they are running, still running or not, by either doing this sudo jps to know what are the Java processes that are running. You can check them this way, or you will also have a web port numbers where you can validate them. So your web port number, web UI port number is for this is 8080, which is same as your Tomcat default port number. So earlier, actually, this was this master used to run on 18080. Okay, so let me change this command for you. Start-all.sh or stop-all.sh. Okay, first starting or stopping both master and worker daemons. So this is the latest as per our binary tarball installations. Use that. And so as per the latest one, as per the latest releases of Spark, so 18080 is not the port number. It got changed. 8080 is the latest port number. Okay, I'm still keeping that 18080 because almost all the previous releases up to Spark 1.5 5 or 1.6, I think. So even till 1.5.2, this 18080 was the port number, web UI port number, where you can access your Spark master. And Spark worker runs on 18081. And similar to your Mapreduce job history server, we also have a Spark history server here, and that runs on 18088. Whereas Mapreduce job history server runs on 19888, and our Spark history server runs on 18088. Okay. Now, this is a TCP IPC port number, inter-process communication port number. So you guys should be able to differentiate that. This 7077 is the IPC port number, inter-process communication, and 8080 is the web UI port number. And sometimes this is something new that got introduced in the Spark 2.0 onwards. I think REST URL. You can access this Spark URLs might be through some RESTful web services as well. I think that's the reason they might have introduced this. But till last versions of it, so we were having only these two port numbers, 7077 for IPC and 8080 for via your web browser. Okay. And one of the workers, that it is alive workers. So 1 cores in use, 2 and memory in use is 8.5 GB total, and no drivers running currently. Status alive, and worker ID is this. So it has given this ID, and this is running on this IP address, and 36201 is the port number on which this worker is running. So it's running on 8081. Let me keep you guys on mute. So is client equivalent to your edge node? Exactly. So client means almost all the places it's edge node only. Okay. So web UI port number, so it's 8081. So I'm trying to access the same thing. So let me, okay, yeah. So it's accessible through the host name, not the IP address. So the worker is running on this. 8081 is the web port number. Okay. So latest is and similarly job history server. Let me see. I think it should, if it is 8088, that means your yarn resource manager, whereas your job history server for Spark, it is 18088. Yeah. So this port number didn't get changed. So it's still there on 18088 only. Okay, so out of all the different components that that you will be observing here, so one is in master, and second one is worker. And generally you don't need to remember the port numbers for workers. Just remember the IPC port number as 7077 for master and browser port number as 8080. Okay. And history server runs on 180.88. So once any Spark job gets completed, so then that will be moved to the history server.
What's the IPC port number for the master?
Master is 7077.
Okay.
Okay, and so this is the IPC port number that we need to remember, and sometimes we use providing this in the programs as well. Okay. So these are the quick info on Spark Master, worker, history server, this thing. So to get started with our programming, we should at least know what is mean by Spark Master and what is its URI, either IPC port number. Yeah, mostly will specify the IPC port number URI only in the programs. So for that reason, we should know the Spark Master. Okay. So when you run a standalone mode, when you run your application in a standalone mode or Spark in a standalone mode, your Spark Master will be running on your quickstart.cloudera 7077 is the IPC port number. So where your master runs. But I told you that when you run your Spark shell, simply the Spark shell, that will not even run your Spark in a standalone mode. That opens your Spark in a local mode, right? In that case, so your Spark Master will be local. A Spark Master value will be local of star. Okay, what does that star represent? We'll discuss sometime later. But your Spark Master URL or Spark Master path that we specify, or we don't even need to specify, by default when you open Spark shell, that opens in a local mode. There, if you refer, your Spark Master will be your local of star. And if you want to open your Spark shell in a standalone mode, then even that you can open by using the command spark -shell -conf -conf. There is a master property, spark.master equal to this value you can provide, spark : this way. So if you don't specify this, by default it opens in the local mode. Or you can also give this way, --master is also there, I think. --master equal to master space your value. This way we'll see that syntax. Now, if you're, so these are the three components that you have, that we have talked about till now. Spark master. So let's say that master might be local or a standalone JVM running. And Spark worker, this will come into existence only when you are running in standalone mode. Otherwise, it's in a local mode. You will not have a separate JVM that will also run in the same local where your master is running. And history server will be different. But along with these three components, there is another very important component that is called SparkDriver. SparkDriver, this is application specific, meaning, so there will be a separate driver for each separate Spark job. So that means if you have 10 Spark jobs submitted at the same time to your Spark master, 10 Spark drivers are running parallelly. In layman terms, or in simple terms, if I have to explain, Spark driver is nothing but your Spark program. So if you have 10 Spark jobs submitted, 10 programs were submitted. Even if you submit the same program from multiple user IDs, that will create multiple Spark jobs, in turn multiple Spark drivers.
Shiva, if we have an same Spark job, we have two instances running by the same user, then it will take two drivers, or it will take the one driver only?
It will still two drivers.
Two drivers, okay.
Yep. So a single job instance will have a one driver, and that driver will be existing, that will last only till the execution of that job.
Hey Shiva.
Yes, Raj.
Is there any limitations on number of Spark driver?
No. So same like, see, this is same like, I think REST web services will useful to submit the job. Okay, yeah, might be Raj, for your earlier question. We didn't use that much. I mean, this is something got newly introduced in the Spark 2.0. Even I'm observing this first time. So for second question, Spark drivers limitation, there is no such limitation. This is equal. This is same as your number of Spark jobs. So same like in your Yarn framework, there is no limitation for maximum number of Mapreduce jobs. If you don't have enough resources, they will be waiting in the queue. That's it. It's not like your job will not get submitted. Same way, here also, for every Spark job, there will be one Spark driver, and there is no limitation on the number of drivers in the cluster. And so the number of active parallel drivers will be decided by the number of resources that you have in your cluster. Let's say you have a 10 node cluster. So 10 node cluster, each with 256 GB RAM and some 40 core CPUs or something. And the containers configuration was like, out of all the 40 core CPUs, 32 were allocated to Yarn, okay, or your Spark master, whatever it is. And so some RAM memory might be 200 or 180 GB allocated for Yarn, okay. So and assume that you have some 32 containers per node. 32 containers got decided or allocated per node, and out of 10 node, across all the 10 nodes, you have 320 containers. Okay, and there are some 100 or 150 Spark jobs running parallelly. So each of them are at least taking, like, if the 100 jobs are running, maybe each of them are taking like 3 containers or 4 containers. In that case, the active containers will be limited by the number of active drivers. The active Spark drivers will be limited by the number of resources that you have, but there is no such fixed limitation that so this many drivers only can be submitted to Spark. Okay, so if you don't have containers available at that moment, it will be waiting in the scheduler for next one to be picked up. Okay.
Thanks, Shiva.
Yeah. So next, so here the Spark driver is like, if you want to compare this, this is a kind of, I should not be calling this as an application master, because even application master is also be running in yarn mode, but Spark driver is, I should call this as your Spark job itself. Spark job, the client, Spark job, the client side. So client side logic or the main logic. So your main method logic. In technical terms, if I have to specify, so you will be writing your Spark program using Scala, right? So in Scala, if you want to start with, if you want to make any application, so what is the minimum requirement? You need to write an object, right? Object, simple Spark. Inside this, you should have a main method. Def main args, which is an array of string. So you will have your programming inside this main method. So the first line of your Spark program will get executed from this main method. Now, so wherever this main method, in whichever machine this main method gets executed, that machine acts as like a Spark driver for that particular Spark job until that job gets finished. Okay, and the process that runs, or the JVM in which this main method starts getting executed, is called as the Spark driver. So I hope you guys understood what is meant by Spark driver. So whatever the process that executes the main method of your client program, that is called as Spark driver. Okay. Now, inside this SparkDriver, so it is now clear that SparkDriver is responsible for execution of your Spark job. So SparkDriver starts executing your Spark program. Now inside this, to get started with any programming, you need a Spark context. So you need a Spark context object on which you have lots and lots of APIs. So on Spark context object, you have lots of APIs available to deal with various operations. Okay. Here we'll see a concept of RDDs. Okay. Resilient distributed data sets. So anything that you have to start programming inside your Spark, you need a Spark context. So Spark context object needs to be created. So let's say that Spark context object, I call this as val sc, the Spark context. So the prerequisite to start programming with Spark is creation of Spark context object. So before you start any operation like reading a file or processing that file or doing anything, so first you should have something in hand, that is Spark context. And to create Spark context, the prerequisite is the creation of SparkConf object. Val sc val conf equal to SparkConf. New SparkConf. So if you compare this, isn't this exactly looking like so your Mapreduce program where we were reading configuration conf equal to new configuration, which reads in all your conf files in Mapreduce program. The Mapreduce, even there we call that as a driver program, right? So we have three components in Mapreduce. One is a mapper, reducer, and driver. Inside the driver, in main method, the very first line that you see is configuration conf equal to new configuration. And once you have the configuration, you create a job instance there. If you guys still remember them, job equal to new job or job.get instance of SparkConf. So by passing the conf object and some name, you create a job instance. And on top of job, you will be reading any files, job.set input path. So you specify path and job.set input format, input file format or whatever, that it has a text file format, and add input paths or set input paths, specify the location of the input directories. So your Spark programming, at least for most of the Hadoop developers, I keep on telling that during their Mapreduce course. So even though if you don't master Mapreduce programming, that is fine, but at least you have an idea of the flow. So that helps even in learning Spark as well. more or less the flow will be little bit similar to that. Okay, so first you create a, in the driver program, so first you create a SparkConf object and you set whatever the configurations that you have to, that you want to, and then using that SparkConf, so create your SparkContext object, and once the SparkContext object is created, so this is like, so now you are ready for doing any kind of processing, like reading a file, so text file, start reading your file, so hdfs colon your quick start m.cloudera 8020 / user / some file. Okay, so once you have SparkContext object, then you can read in your file, and if you read a file in Spark, that creates an RDD. What is RDD and what are the different ways of creation of an RDD, that we'll see in the coming topics. But for now, you treat that RDD is the basic or the very important component in the Spark programming, in the Spark processing. So anything that you deal inside Spark is in terms of RDDs only. Any file that you read or you write or you process is through RDDs only. Okay. Or in simple terms, for layman terms, until we discuss additional details on RDDs, treat RDD same like a file. RDD is nothing but a file inside Spark. Okay. So coming to the hands-on part of it. So now we talked about SparkDriver. So inside the SparkDriver, what is meant by SparkDriver? The program in which the main method gets executed, and inside the driver, the very first steps, the beginning steps are like creation of a SparkConf object and set your properties, any properties that you want to set, and bare minimum. So we'll set two properties mainly. Set master. So if we set this master to this will, your job will get submitted to standalone Spark cluster. Okay. So if you set this, this will get submitted to your standalone Spark cluster. But if you don't set that, let me copy paste here. If you don't set this, by default, it would be local off star. So which means your Spark job will get submitted or executed through local mode. And additional another parameter or configuration that we set for any Spark application is set app name. Your application name or job name, what do you want to give? The same job name that we were giving here. In Mapreduce, we were giving the Mapreduce job name, right? So similarly here, let's say if it is a word count, so specify the word count. So by setting these two bare minimum configuration properties, we create the conf object from the SparkConf class. And once you have the conf object, you create the SparkContext. And once you have the SparkContext object ready, you start reading your files and creating RDDs and doing whatever the operations from there onwards is specific to each application. Until then, for any Spark application, these three steps are the beginning and the mandatory steps that you do, or at least these two. Okay, so you might read a file or might not read a file. That's up to your wish. But first you will create a SparkConf object, and using that SparkConf object, you create a SparkContext, and on top of that SparkContext object, you start your programming. Okay. So if my Eclipse is downloaded, let me see. Let me put that. Let me put that as well in this. I'll create another Eclipse folder for this to get started with our programming. Sorry. Sudo mkdir/opt/eclipse and sudo chmod -r777/opt/eclipse. Okay, so let me create a shortcut for this. Make a link. Okay. So this is starting your Scala Eclipse IDE. Eclipse launcher. Okay, I'll put that Scala only. Now, so anything that you want to build as an application, Spark application, that you start writing that in Eclipse, and you prepare a jar file, same as your, if you observe the life cycle of your Spark jobs or Spark programming or Spark development, so it almost looks similar to your Mapreduce way. Okay, so the same way you create conf and job and specify all the mapper, reducer, input path, output paths, everything. So here also you'll specify input paths and write output into output different locations and do all this stuff. And once the development is done, you build a jar file, even in Spark, same like your Mapreduce. and you submit that jar using a command called spark-submit. So spark-submit command, using that spark-submit command will execute that jar file. So whatever you do, this stuff using these steps, creating a Spark program in Eclipse and building a jar and running the jar using the Spark submit, this is a batch mode of execution. If you have any batch tasks that needs to be done, you can do that way. And even if you are writing a very lengthy Spark application, most of the times the developers will start testing their Spark lines of code first in the Spark shell using that the interpreter. So inside that Spark shell, you will first validate all your Spark lines of code that you want to execute and run that on a sample test piece of code data and observe the results. And if everything is fine, then you put it into your application and build the jar, then submit that jar whenever you want to. Whereas in Mapreduce, that facility was not there for us to test each line separately, to debug that easily, each line separately. So since you have the Scala shell support, Scala supports the shell mode of execution of your commands. So you can practice all your Spark commands and Spark lines of code first in the Spark shell, and if everything goes fine, then we build it as an application. Okay, so even we will also do the same pattern. So now when if we go by that pattern, so if we have to start our Spark shell, so we'll specify Spark-shell. So if you don't specify the master or master equal to local of star, so this is from this terminal, I started one Spark shell with one Spark shell in a local mode, and I'll run one another. Let's see, I'll run this Spark-shell master, which has your quick start dot cloudera colon 7077.
Shiva, why are you opening two? Why can't we just work on one of them?
Just wanted to show you different ways you can open your Spark shell. That's it.
Okay.
Okay. So we'll anyway practice only one, our local mode only. So since I was always keep telling you that there are different modes, right? At least local and standalone, I have been highlighting till now. So you can open Spark shell in a standalone mode also by specifying the master URI. If you don't specify master URI, if you just point to local, that is your local mode of execution.
So Shiva, we don't have to give the conf spark.master command. We can just work it out with --master, right?
--master.
Okay.
Okay. So remote RPC client disassociated, likely due to containers exceeding thresholds. So the problem is I don't have much containers on the yarn resource now. I don't have much containers on this machine available. So running parallelly at the same time, it's not allowing me to do that. But yeah, one after the other, you guys can try it out. So maybe once you practice in a local mode, and then maybe later you practice that in a standalone mode. Okay. Now, so when you submitted this Spark shell behind the scenes, if you check here sudo jps-lm, so grep spark, you will find your Spark shell is started. Okay, see that was submitted to Spark submit command using this --master as local of star, and the name of that application that got executed is Spark shell. So if you want to change that application name, again you could have given, or you could have passed one another parameter --, name, and give a different name whatever you like to. So now when you open a Spark shell, it could be either in local mode or standalone mode or whatever it is, or yarn mode. So whatever the mode it is, if you open a Spark shell, by default it creates that SparkConf object. It only Spark shell itself takes care of creation of a SparkConf object and SparkContext object, and it creates that SparkContext object and it gives you that object variable as SC. That's the reason if you observe these messages, so it is setting this default log level to 1, and this change has been introduced from Spark 1.6 onwards. Prior to Spark 1.6, in 1.5 or 1.4 or other early releases, so you were seeing all the info messages also in the Spark shell. Now, so once you see this here, one Spark context, so use an existing Spark context, some configuration may not take effect. Spark context web UI is available on this. So once your Spark context is started for a particular job or any, I told you, right? So you will have a separate driver for each Spark job, and inside each separate Spark driver, so these two steps are common: creation of a SparkConf object and then context. Once you create a Spark context object, that Spark context will also provide a web UI for us, or sometimes we call this as a driver, Spark drivers web UI, because each Spark driver will have only one Spark context. Either you call this as a Spark context web UI or as Spark driver web UI, it doesn't make much difference. So they both are interchangeably called keywords. Most of the times I call at least Spark driver web UI port number. And here in Spark shell itself is a driver, and that is creating your Spark context object by default by pointing the master to local of star and name as Spark shell and it opens the web UI port number and so on, so this port. You can access that here. So by using 4040. So if you have more than one Spark shell open, so for each driver you will have a separate port number. Okay. So for each Spark job, you will have a separate Spark driver. That means separate SparkContext. That means separate web UI port number. And these numbers start sequentially starting from 4040. So for the first time, if you are submitting any Spark driver or Spark job, you will be given with 4040 port number for your application. If there are already one Spark job running, then you might get 4041. If there are already two running, you will get 4042 port number. This port number to track your Spark jobs is not fixed. This is given based on the number, the active Spark job number that you got at that execution time. How many parallel active jobs that are running that moment, based on that this port number will be decided sequentially starting from 4040. Now, so you will get to know when you submit a job to your Spark submit, or when you open a Spark shell, you will get to know your Spark will print you this message. SparkContext web UI will be available on which host name and port number that is available. And that way, so by default, your Spark shell creates a SparkContext object for you, and that SparkContext object is available with SC name. Now, anything if I want to read a file, sc.text file, and read in your files from Hadoop fs-ls/user/cloudera.
Shiva?
Yeah.
I'm getting SQL context available. Is that okay? I don't know.
Oh, what is it?
I'm getting SQL context available.
Yeah, that is okay, not a problem.
Because
But
my Spark is on Hive, I think that's why. Is it okay?
yeah, that is okay, not a problem. We'll come to that SQL context, SQL context as well. Okay. So for now, we'll be focusing on the Spark native, and in Spark native, if you want to start programming, so the bare minimum thing that you need is Spark context object. Okay. So for now, let's discuss the Spark context. So I'll take any simple file to get started with. Yeah, so I'll just take this simple readme.md file to process maybe basic filtering or transformation kind of activities. So I'll put this into my local and upload this to here. So Hadoop fs-put. I can read from my local file system also, but let me push this to Hadoop only. Now, let me specify that path /user/cloudera/readme.md. So if I create this, it's generating res0, which is an rdd of string. Okay. Ideally speaking, I should collect this rdd into one variable, something like this, one variable or a val input. Now input is an rdd of string type. So in simple terms, this is a rdd of lines. Each line is treated as like a one big string, and that string is the, so it's just rdd with one column or data type. Okay, so rdd of string type. Each line is one string. Once you have rdd, on rdd's, this rdd, you treat this exactly like a collection, and this is like a collection only. So when I read this file, readme.md, so how it loads into the rdd is, this is one string, and this is empty string, and this is another empty, this is another string into that rdd. So this is rdd is nothing but a collection of your strings, right? It's a list of your strings.
Can we consider rdd as like a data type something?
Rdd like a data type.
Data set maybe.
Yeah, rdd should be considered as like a data set, not as like a data type. Okay. So rdd is same as your data set. It's same like your file only. Okay. But in collections point of view, or in technically speaking, functionally or logically speaking, rdd means a file or a data set. But technically, it's a collection or a list of strings or whatever the data type that you pass. Right? So here your file means, or data set means, your collection of strings, collection of lines, collection of records, list of records. Correct? Isn't it? Say yes or no at least.
Hello.
Yeah.
In the Spark shell, you did not create an object for SparkContext, right? But you're able to access the SC variable there, like val SC.
That's what I told, na? By default, your Spark shell itself will create for you.
Okay.
So if it is your own,
Yeah,
if it is your own program that you are writing in your Scala Eclipse IDE, you have to create them. But if it is Scala shell or Spark shell, by default, your Spark shell will create SparkContext for you. And
okay, got it, sure.
Yep, it gives you as a variable as SC. Now, you tell me that whether you understood this logically or not. For now, I'm not talking about all the RDD features here. RDD is nothing but a data set or as a file in layman terms. or even logically. Okay, in logical terms, RDD is nothing but a data set. Technically speaking, as a programming terminology, this is nothing but a file is nothing but a list of, I'll say, forget about RDD also. I'll say a file is nothing but a list of strings, means an array of strings.
Shiva, like you're saying that this is like a list of strings, but if we have something else as an input, for example, not a file, maybe coming from any other source, then how will it handle it? Like RDD is only for files, you mean to say?
What is the other sources? You tell me which is not a collection.
I don't know. Maybe it's coming from DB2 or something like that.
Oh, why is not a collection of records?
Collection of rows, right?
Collection of rows, yes. Collection of string. Row means again another string.
Okay. Okay, and even if the Twitter inputs, there would be rows. Okay.
Yes.
Yeah. Okay. So there is nothing other than collection, right? There can't be any instance where we could have
Yes.
randomized things. If it's random, then.
So even if it is randomized, I mean, you don't have any structure. That means.
Yeah.
So how does that? That's a random string. One string.
Okay.
Okay.
As of now, I'm not coming up with something, but if I do, I would just shoot in a question for you.
Okay, no problem.
Shiva.
Yes, Kalavani. Yep.
Shiva, suppose if the file has numeric value and that is character value, so even the RDD considered as a numeric, as a character, as a string, right?
Yes.
Are you meaning?
Yes. Anything is a string. In any programming language, by default, everything can be represented as a string. If you need to further process them in arithmetic operations or those things, then you might need to convert them into your own appropriate data types. Otherwise,
okay, if it is RDD, then it should be a string only. I mean, it will convert as a string only.
Yeah, by default, it loads that as a string. Okay. And programmatically, in any programming language, it could be Java or Scala or whatever it is, string can be used for any data type. Inside a string, you can put a decimal value, you can put a float value, you can put an integer value, you can put anything, but you put them in a double quotes. That becomes automatically a string. Did you get it?
Hi Shiva.
Yes.
Shiva, I have a question. Just like what I got from this is just like the number of lines in this file is now the collection of strings, and there must be an empty lines, and every line has been a string by a end line marker. This is the RDD data right now.
Yes.
And there must be also empty lines here because we have the spaces in this file.
Correct. Even those are treated as like a one empty record.
So we have a list of all the strings, and all the strings having each line, and every element has each line along with the spaces, along with the empty lines.
Correct. Exactly. Now, if you see in my editor, in my notepad or the gedit of this file, so I put my cursor at the last line. You can see the line number as 99, right? So that means total 99 lines are there, including your empty lines. So now, why don't we try it out? Input.count. So there is a function available on this. Input path does not exist. It is referring to your local file system by default. Okay. So file colon. So I should have given maybe HDFS. Then I'll give this as a HDFS colon quick start dot Cloudera colon 8028. Okay, so quickstart.cloudera colon 8020 slash using this and input.count. See, so it displayed me the 99 value there. So that means total 99 lines are there. 99 records are there. And each record is nothing but a one line of string. What I am trying to convince you guys is that RDD, in terms of Spark terminology, it has its own significance, it has its own characteristics. But one primary thing that you guys should keep in mind is that RDD is nothing but a one collection, one array, one list of strings or list of any data type. It need not be always a string, but when you load a data from a file, mostly that would be a string. When you read contents from a file, then that might, most of the times, 99% of the times, that creates RDD of strings only. But that is not limited that RDDs can be created only on strings. RDDs can be created with anything. And let's not talk about RDD complete features here. So what I'm trying to convey here is that RDDs, treat that as a list. Is it clear?
Yes, Shiva.
Okay. So treat this as like a collection, or just treat this as like a list. Now, since this is a list, so I have explained some important functions in the morning on list. Input dot. So what are the functions that I have explained? So FlatMap, right? So input, in input, so my input is nothing but a collection of lines, right? Each line is a string, and I want to process each line. So input.flatMap, for every line, what I'm trying to do is line.split by space. So what it produces for me, it produces all the votes of each of this thing. And I want to, so again, this is, the result is another list, right? So if I apply flat map or map or filter, so for all these three operations, the result is again another list. For reduce, it is just one value, and for each, it is just a kind of execution, right? And here, flat map again returns another list with all these words. Now, I'm going to apply a filter. So for every word, so if word dot contains Spark, so I want to print only them. So for each, println. So I hope everyone is able to understand this one line of Spark code. So in this RDD, I'm splitting each line by space. So I'll get the complete total words. and out of all those words, and in every word I am checking whichever word that contains Spark, return another list with only those words that contain Spark keyword, Spark in them, and I am printing those words using this for each of println. I used all the three collection methods here: FlatMap, filter, and for each. So initially for you guys, this kind of chaining of this is a chaining style of programming. This might be a little bit confusing, but this is the most popular way of writing Spark code, and that makes the Spark code so efficient and readable as well once you get started or once you get used to this syntax.
Shiva, after you're done with this, can you just send me those two commands of the val input and the those two commands through an email or something? I just want to test it out.
Why not? I'll give you here itself.
Yeah,
I'll put you in the notes file. I'll put you in the notes file. But I want you guys to understand each one of these small pieces of this code, because since you are getting started with the basics.
Yeah, this one I was a little bit confusing, and I know this is apparently supposed to be really important, but I think I lost you here, so that's why I want to go.
So that's why just stop me here if you are not able to understand. Treat this input is nothing but a collection, right?
Yeah.
Okay.
Basically, the text file you're passing it to the input parameter.
Yeah. So wherever you are not able to understand, parse your code there, break your code till there. So what are you doing here? So FlatMap. After FlatMap, you will get a list, and if you want to print all of them, you print them.
Okay.
Okay. Or even if you don't print, it will give you a another RDD. Okay. So this input.flatMap. If this is clear, right? So every line you are trying to split this by space.
Yeah, this is okay.
So that in turn returns another RDD. That RDD. So if you want to see the contents of RDD, either you apply the for each for every line, or you apply. There is another method that is available, collect. Okay. So there is available one another way of. Okay. Or if I want to make you this even more simpler. So val flat words equal to the split by. Same like big, if you break this into too many lines, you have to create so many aliases or RDDs. So here flat words is like nothing but another RDD of strings. Now you have, I have to filter this out. Okay. Or if you want to check what are the, or you want me to check what are the contents of this?
Yeah, what are the contents of flat words? Yeah.
See, flatwords.collect. This is nothing but
flatwords.collect. If you type on the screen, it will basically print ln or echo the flat word contents.
Yes, but not the entire contents, but it only takes only the top few values, and then
What's the limit of this? What's the limit of the collect?
Exactly, I don't know by the size, but it displays mostly around 3-4 lines of code. 3-4 lines.
If you want to extend it, then do like how we have more.
We use for each.
For each, okay.
For each println, this prints everything.
Okay.
It prints all the lines.
All the words in the line.
Yep, all the words in all the votes in flat that flat map RDD. So this has exceeded that 500 limit. That's why terminal edit settings. Okay. Sometime later I'll set that. Not a problem. So either if you want to see the contents of an RDD, either you go by collect or for each println. Now you have your votes, flattened votes in this flat votes RDD. I want to filter them out. Okay, only Spark votes. I need only Spark votes, flat votes dot filter, because this is another RDD, right? On RDD is nothing. Again, I will not be always using collection or list keyword. From now onwards, RDD means it's a collection only. So since this is an RDD again you can apply filter. So for every word, I'm going to check this word dot contains. So on a string, I have a contains method that is available. So whichever strings that contains Spark keyword, they are present in this. So in this Spark words, now Spark words dot
contains
collect, right?
Yeah.
So these are the words that has Spark. This is one word, and this has Spark, and this is another word.
Can we replace that word Spark that we just found as, say, capital SPRK?
Yeah, you can do that as well.
Okay. Can you show that?
Okay, why not? You are giving me exam on the fly.
I'm seeing what can come my way, so I'm getting it done from you. As simple as that.
I'll come with different examples in mind. Okay. So something like string operation. For every word, if word contains Spark. For O dot
Contains.
No, not contains. It just checks whether it is present or not. There
Basically,
should be
find and replace. How do you do that? That's
yeah. So we'll be doing this. If I have Eclipse, that's even more simpler for me. So it gives me all the different APIs. Or let me open this string replace. Okay. In Scala. Yeah. So here you can see line dot replace all. So whatever it is, you have to try. So that way, if I have to do this, O dot replace all or replace either of them, I think it should be okay. So the Spark with Spark. Okay. Now the Spark words dot collect. FlatMap dot only one place it got changed, one place. If I have to change all of the places, the same.
Shiva, you have to use the replace all.
Yeah, that's what. So it got changed only once in the line, and if you want to change all the places, use the replace all. And so use this again. Or for every.
Hey Shiva,
Yes.
But couple of Spark has a space in front and all that stuff, right? So it will not consider as a Spark, but it's a
That will
space
not
and
consider, and even small spark is also not. I mean, this is what I wanted to change, and this is a capital S spark that it has, so that is not getting changed.
yeah.
Probably
Okay.
we might have to use the ignore case thing, right?
Yeah, I mean, yeah, you guys try with all these syntaxes. Mostly for these kind of syntax things, I'll rely completely on the developers. So what you guys need to understand is the concept,
Okay.
the purpose, how you can use them. If you are clear on them, so trying out syntaxes is not a big deal. If you said, if I tell you the what is the API, so you can start doing them.
Okay.
So for that, Google is there for you. See, now when I used capital S Spark, so all this Spark got changed to capital Spark, and this Spark got changed to capital Spark. Everything, right? Okay, so now here on this RDDs, you have seen a flat map, map, filter, for each, and collect operations. And count also we have seen. Right? Any questions so far?
Shiva, I hope you're going to be jet lagged today also, so that I can ask you during the daytime.
Okay. I mean, any questions on this so far? Like,
No, sure, we're good.
okay. So now, so you are clear that from the programmer's point of view, the first few things that we do. So in order to write any SparkDriver, you need a singleton object and main method, and inside that SparkConf and SparkContext. But when you are starting with development inside your Spark shell, or when you are executing inside your Spark shell, so all these things come by default, and you will get your SparkContext object as a C. And once that is available, you start reading your files using the text file, or yeah, for now just start with the text file. And I specified my HDFS URI to pick my HDFS file path, and it read that file and created an RDD. And since an RDD is nothing but a collection, I applied all my collection methods on this. I applied FlatMap, I applied filter, I applied for each, I applied map, I applied all these things, right? So when I run this flat map, okay, or a map, and I run this, so did I see any result here? No. But when I run this sparkcodes.collect, I can see the result. So that means there are some statements which don't produce you the results immediately. There are some methods that produce you the results immediately. Some which don't produce results immediately, and some which produce results immediately. Same like your pig Latin programming, where any pig command other than dump or store, other than dump command or store command, whatever the pig command that you submit to your pig engine, that will still get that will just get compiled or just get added to the list of commands to get executed. Here also, in Spark, we have two types of operations that can be done on RDDs. So one is a transformation operation, and second one is an action. So this is a transformation, right? So every word replace Spark with Spark. This is one type of transformation. You are transforming this small Spark into capital Spark. And any transformation operations that will produce again another RDD as a result, all those are transformations most of the time. So that's the reason your FlatMap, map, filter, all those things are transformation operations. And anything that you run, a collect means you want to collect all the results into one place. That is a kind of aggregation. An action that needed. A collect or println on for each or count, all these are actions. And when you run actions, you will get results. When you run transformation, you will get another RDD as a result. That's it. You'll not get the actual result values displayed or executed. So you will see another RDD being created. Okay. There is a lot more on that, those two types of operations to discuss, and what else, what other operations are come into those two categories. What else will come under transformations? What else will come under actions? We'll discuss later. But for now, whatever we have seen so far, so I thought you guys will capture these points.
Yep.
Okay. Now, so when you run this any action, so that is where your execution will get started. So for your transformation, there is nothing that gets executed. Only when it encounters any action operation, then your actual execution happens. Okay. So when actual, yes, this is called lazy execution. Exactly, Dhruva. Okay. So when your execution is started, so how does that pattern will go like on high level? This is very, very high level. So where is your, in your case, your Spark shell itself is like a driver in this, right? Because Spark shell provided you the SparkContext object. And wherever, in whichever program that you create SparkContext, you call that as a driver blindly. Whoever creates a SparkContext object, you call that as a SparkDriver. That's a blind formula. Now your Spark shell itself is acting like a SparkDriver for you. And this is submitting, or this is executing the tasks for you. So your Spark context on the web browser, it is running on 4040, right? Earlier when I started just the Spark shell, this page was empty. Later I ran so many things, so many operations, out of which all the actions that you can see here. So when I ran the first time count to print the 99 value, this is that. Next when I ran for each, this is. Next when I ran collect, this. Next when I ran for each. After that I ran all collects only.
Okay.
So that means for every action that you submit, there will be a backend Spark job that gets executed. Since your Spark 1.6 and above, the log level is changed to 1. You are not able to see that Spark job submission messages in the console. But in the earlier releases of Spark, we were able to see that Spark job submission messages even in the console itself. Even
so is there a way to on it? Is
yeah,
there a way to on
yes,
it?
yes, that's what I'm coming to. If you want to see them, you just enable that log level as info.
Okay.
But your Spark shell will be flooded with too many info messages. That's the reason they have suppressed all those messages, informational messages. But some places, at least for explaining few things for you, I'll make that log level as info, and I'll explain you those steps involved in the Spark job to explain the Spark job anatomy and a few other concepts. I will anyway enable them, and I will show you those log messages. Okay. Now, for every action, you are able to see a backend Spark job getting submitted. And how does this happen? Your Spark driver sends those requests to your Spark master. Spark driver sends those requests to Spark master. So requesting that, so I need this task to be executed, this action to be executed. And Spark master provides a list of Spark worker machines. And then once Spark master provides the list of worker machines to execute the task, then Spark driver will directly communicate with those workers, and workers will execute those tasks inside them. And here, I'm not talking much internals of all these things at this moment. For now, Spark job and each of these are running, each Spark job ran two tasks inside them. Okay, so how these tasks or how these stages and all these things, all low-level internal details, we'll discuss slowly. But now, the basic high-level architecture you should be clear with. So the Spark driver negotiates with your Spark master to get the list of worker nodes, and once it gets the worker nodes, it submits the tasks to worker nodes, and once the worker nodes finishes the execution, so the driver will get the results back to it. This is a bit high level. Okay, Spark applications will have a driver program that launches various parallel operations on the cluster. Driver program contains our application's main method and defines distributed data sets, which we call them as RDDs, on the cluster, and then applies operations to them. What are those operations? Two types of operations: transformations and actions. And driver programs access Spark through a SparkContext object, which represents a connection to a computing cluster. In the shell itself is our driver, and SparkContext is automatically created as SC. And then we can run various operations on this SC and create RDDs and whatever you want to do. Driver programs typically manage a number of nodes called executors. And once the SparkContext is kickstarted in the driver program, and if it has to submit its tasks, it will submit its tasks to worker nodes. Inside worker nodes, the JVMs where your tasks will run, we call those JVMs as executors. In terms of Spark terminology, the slave machine is called as worker node. Inside that slave machine, the JVM process that executes your tasks is called as executor. Okay, and this slide also we have discussed. The first step of any SparkDriver application is to create a Spark context. But to create a Spark context object, we need SparkConf object. And the SparkConf stores the configuration parameters that our SparkDriver application will pass to SparkContext. And the two mandatory, or not, I should not be calling them as mandatory. The two minimum properties that we specify is one is a master and second one is the application name. Is it same as log4j? Yes, Raj. Okay. So anyway, I'll show you that, don't worry. So if you want to create a SparkConf object inside your own program, so we use this line of code, val conf equal to new SparkConf, set application name as application name, set master as master wherever you are running, Spark : your master host name, so host name of your master, and 7077. And any other configurations that you want to set. So when you are running different executors, if you want to increase your executor memory from the default value, you can set that as well. And similarly, so when you start your Spark shell, if you want to see what are the default configurations that were set up for your Spark shell, there is a configuration property for that as well. So if you start your Spark shell with --conf spark.logconf equal to true to log the effective Spark configuration as info when Spark context is started. So since the log level is not info by default, you'll not be able to see them. First, you have to open your Spark shell with log level as info, and then you set this property as well, --conf spark.logconf equal to true. Then you will be able to see all the configuration properties there. And I'll show you this Spark properties will sometime